The idea of the atom was introduced by Democritus about 2,500 years ago, but was widely considered ridiculous by people of the day. The idea was brought back by John Dalton, an English chemist, around the year 1800 in the form of the billiard ball model. Dalton did many experiments on gas properties such as pressure. He concluded that gases consist of small, singular particles in non-stop random motion. He researched compounds and concluded that they consist of different elements or ratios, which could only happen if elements were made of separate particles that cannot be subdivided. He made models out of wood balls because he believed them to be solid, hard spheres. The plum pudding model was proposed by William Thomson and widely supported by Sir Joseph John Thomson. It suggested that atoms were spheres made of positively charged matter inside which were the negative electrons. Thomson experimented with cathode ray tubes, sealed glass tubes with almost no air in them. Voltage is applied to two electrodes at the end of the tube, causing a particle beam from the negative electrode to the positive electrode. Using the fact that the cathode ray went from the negative side to the positive side, he concluded that the ray was negative, hence electrons. This model was proposed around the year 1900. The nuclear model was proposed in 1911 by New Zealand chemist Ernest Rutherford. It is the first atomic model to have a nucleus. It suggested that rather than the atom itself being positively charged, a nucleus in the center was positively charged. Negative electrons orbited the positive nucleus. The experiment was that a radioactive source was emitting alpha particles, which are positively charged, pointed through a narrow slit in a lead screen toward gold foil, to make it light up if alpha particles hit it. Most alpha particles went straight through the foil, implying that atoms were mostly empty space, but some did hit and hit very hard. This led to the explanation of heavy, sturdy, positively charged nucleuses at the center of each atom. The solar system model was proposed by Niels Bohr from Denmark in 1913. It describes the property of electrons in terms of a set of possible values. Atoms interact with, meaning they absorb or emit, radiation only when electrons jump between these possible stationary states. Bohr hypothesized that light radiated from a hydrogen atom only when an electron transformed to an orbit closer to the nucleus. Bohr found that the ratio of an electron's energy to the frequency of their orbit of the nucleus was equal to Planck's constant, which is light's energy to its wave frequency, and the shortest length currently thought to be possible. The quantum mechanical model was proposed in 1926 by Austrian chemist Erwin Schrödinger. Rather than defining an electron's exact path, Schrödinger used math to determine and describe the likelihood of finding an electron in a certain position inside the atom. He described the electrons surrounding a nucleus as a cloud, rather than specific orbital paths. You were more likely to find an electron in the denser part of this cloud.